Hello and welcome to our first video, this one on expanding and factorising brackets, which obviously you've met at GCSE, but we will be going into a little bit more detail. So expand 3x minus 2, 4x minus 3. There are many ways that people are taught to do this at schools. Some use FOIL, first, outer, inner and last. Some draw lines joining the terms together. Some people use a little grid. Nevertheless, you're going to end up with four terms, however you do it. 3x times 4x is 12x squared. 3x times negative 3 is negative 9x. Negative 2 times 4x is negative 8x. And negative 2 times negative 3 is plus 6. And then when we collect the x terms together in the middle, we get 12x squared minus 17x plus 6. If we're asked to expand 5x minus 2 all squared, that is of course the same as 5x minus 2 times 5x minus 2. So using the same approach, we end up with 25x squared minus 20x plus 4. In this question, we've been asked to expand x plus 2 cubed. Now you do get asked to expand 3 pairs of brackets at GCSE, but they do tend to be different brackets. In this case, we're timesing x plus 2 by itself 3 times. So I've started off by doing x plus 2 times x plus 2, which is x squared plus 4x plus 4. Then I've multiplied everything in that bracket by x, and I've also multiplied everything in that bracket by 2. And rather than writing out in a single line, I've actually put in columns each of the different powers of x. So x cubed is on its own, but we've got a 4x squared and a 2x squared in the second column. We've got a 4x and an 8x in the third column, and then a plus 8 also on its own, giving us a final answer when we add them together of x cubed plus 6x squared plus 12x plus 8. Please pause the video and try these questions yourselves. The answers will be revealed on a different PowerPoint presentation. So now we're going to look at some factorizations. In this question, we've been asked to factorize fully 6x squared plus 10x. The only number, apart from 1, that goes into both of those terms is 6. But we can also take x out as a factor, so 2x in front of the brackets, multiplied by 3x plus 5. And the reason it says fully is because if you factorized out the 2 or the x, but not both, then you will have only factorized it partially. You will certainly have factorized a quadratic expression before. In this case, we've got x minus 2 and x minus 11, because negative 2 plus negative 11 is negative 13, and negative 2 times negative 11 is the positive 22. In this quadratic expression, the coefficient of x squared is more than 1, which means that we're not just going to get x and x in our brackets. In this case, 3x squared plus 7x minus 6 factorizes to give you 3x minus 2 and x plus 3. Which you can check by expanding the brackets again. There are many ways of solving or factorizing quadratic expressions, which I won't go through right now. But in your next lesson, I will be showing you an unusual approach to factorizing quadratics. At GCSE, you will sometimes be asked to factorize something which includes a difference of 2 squares, but also multiplied by a common factor. In this case, if we factorize out the 5, we get 5 brackets x squared minus 9. And hopefully you recognize that x squared minus 9 is the difference of 2 squares, giving us a final answer of 5 brackets x minus 3, x plus 3. Please don't divide by 5. Some people do that. Just leave the answer as x minus 3, x plus 3, but the 5 is definitely part of your factorization. However, what you don't tend to get at GCSE is a common factor followed by a quadratic, which is not the difference of 2 squares. So in this case, we could take 4 out from each term, because each has a factor of 4, as well as an x. So we get 4x outside our brackets, and then inside our brackets we have x squared plus 6x plus 5, which factorizes itself as a standard quadratic factorization to x plus 1 and x plus 5. So again, our final answer has to have all those components, 4x, x plus 1 and x plus 5. Again, please pause the video and try these 5 factorizations. Again, the answers will be on a separate PowerPoint. Just to keep you occupied, we have 4 more examples of expanding and 4 more examples of factorizing fully. Again, the answers will be posted in a separate PowerPoint slides. And also, just to give you something else to do, we have 10 expressions to fully factorize. Again, answers will be revealed in a separate PowerPoint.